everyone. In this video, we'll be continuing with the empirical formula calculation once again with the usage of the formulas, right? So here we go with the question what has been left for us. Here we have on analysis, a substance was found to contain the carbon percentage is given as 54.54% and hydrogen is found to be 9.09% and oxygen is 36.36%. From this given data, here we have provided with a vapor density in this question. Vapor density of the substance is found to be 44. Using these data, we need to calculate its empirical formula and molecular formula, right? So in this numerical, we need to make use of the formulas what we have discussed earlier in the empirical formula, right? So now here we go with the answers. Now, so whenever empirical formula is been asked, so we are aware we need to create a table which consists of 5 margins. So over here element, first column takes element. So what are the elements listed out here? Carbon, hydrogen and oxygen. The second column we need to write its percentage composition which has been given. So it is 54.54% for carbon, 9.09 for hydrogen and 36.36 for oxygen. The third column we need to write its mass number, that is atomic mass. So when we look into the atomic mass, carbon will be 12 and hydrogen will be 1 and oxygen is 16. Oxygen is 16, right? So what we need to do is we need to, the third in the fourth column, we need to do atomic mass ratio calculation, that is given percentage by its atomic mass. So given percentage for carbon is 44.54 divided by 12, we'll be getting the answer as 4.54. These things to be done manually. No calculators are allowed for the board exams for 10th standard. So kindly get prepared how to calculate manually, okay? And hydrogen is 9.09 by 1, we get the same answer. And for oxygen it is 36.36 by 16, we found to be the answer as 2.27. On simplification, we are getting 3 different answers. So in the next step what we need to do is we need to find the least value among these 3. So we found out the least value is 2.27. Therefore we need to divide this value entirely in this group. So 4.54 by 2.27, and which gives you the value is 2, and 9.09 by 2.27, its value will be 4, and for oxygen it's 2.27 by 2.07, it is 1. Therefore we got the simplest whole numbers, and thus we can derive the empirical formula from this. So empirical formula of the compound, over here it is given, we can write carbon value is 2, C2 and C2, and hydrogen value will be 4, H4, and oxygen is 1 in number, so O1. So this is what empirical formula is. Every formula will have their own mass or weight. So likewise, for this formula we have to calculate the weight of this compound, so that has been called as empirical formula weight. So using that molecular mass only, using the atomic weight only, we can be able to calculate their masses. So that carbon mass number is 12, so 2 atoms, hydrogen is 1, so 4 atoms of hydrogen, plus oxygen is 16 in number, 16 into 1. So when we do the simplification, we finally get the answer as 44. So 44 is the empirical formula weight. Now in the question, so we are provided with a vapor density data. Vapor density is 44. It's nothing but empirical formula weight is only represents vapor density. So now let us use this formula. From the given vapor density, we will be using the formula, vapor density formula, using molecular weight is equal to 2 into vapor density. Therefore 2 into vapor density as per the question is 44. So we get the molecular weight value as 88. Since we know empirical formula weight and molecular formula weight, we can apply this formula. So what is the second formula we have to use in this numerical? Molecular formula weight is equal to N into empirical formula weight. Therefore from this calculation, molecular weight is 88 into N into empirical formula weight is 44 from this numerical. Therefore on simplification, N value is found to be 2. N value is found to be 2. So we got the value of N and we got molecular weight. Therefore using these things we'll be able to calculate the molecular formula. So molecular formula is equal to N into empirical formula. Molecular formula is equal to N into empirical formula. So molecular formula is equal to N value, we know it is 2. So substitute 2 over here, and into empirical formula we know it is C2H4O1. C2H4O1. Thus molecular formula of a compound is C4H8 and O2. So this is the molecular formula of the given compound. So whenever the question has been asked to calculate the empirical formula and molecular formula, you have to do the calculation like this. Is it clear, all of you? Is it understood how to do the numericals for the calculation of empirical formula? So we need to make use of three formulas when vapor density data is provided in the question. Okay, so this is how we need to do a empirical formula calculation and when vapor density is been provided in the question. Thank you so much for watching.